We just before lunch, we talked about some of the commands of the batch system and what it was. And you had some exercises to try where you just tried submitting a simple batch script and then looked at tried doing this control show job on it to see some information about it, and maybe also try to do the job usage and things like this. So, but you can get to do more about that in a little while when we go to the simple examples. So now we are on to using the different parts of Kebnekaise. As I said in the introduction, Kebnekaise is a very heterogeneous system. So it has many different types of CPUs and GPUs. And because of this, you can also, if you need that, do constraints so that you run on only one type of node. And you also have to ask for CPU resources, GPU resources, and large memory resources, depending on what you need. So it's important that you ask for GPU for the resource Kebnekaise minus GPU when you do a project proposal, so that you can actually run on GPUs if you need that. And you should always ask for a small allocation on the regular Kebnekaise resource, the CPUs, because you almost always need to do some CPU work. There is only a single partition, batch, that you can submit jobs to, despite this, that it has many partitions. And the system will then handle figuring out what partitions the job should be sent to based on requested features or constraints. So let's try to solve. Let's try to do an SQ here, because then you can see some of these. I'll do as info instead, because then you can see the partitions here. There's batch, which is the one that you submit to, but there are also other partitions, separate one for the Skylake ones, Zen 4, Zen 3, GPUs, etc., etc. For those you don't submit to, you submit to batch, and then the system figures out which of these partitions it goes to, depending on various constraints, including that you are asking for GPUs, you're saying which type of GPU, and things like this, but you can also tell it which type of CPU. So the CPU only ones, there are the Skylake ones, and you can see they have different number of cores. This matters, and this is why you can at most get 28 cores for the Open On Demand right now, because it will pick randomly between those. The type is Skylake. These are also the constraint Intel underscore CPU. This is Zen 3 and Zen 4. Those two are both in the AMD underscore CPU partition. And you can use a constraint to get, for instance, only a Skylake, or only a Zen 3, or only a Zen 4, or either of those two. For the GPUs, there are also several options where you can tell it which type you want here. And there's the large memory. So how do I do when I want to request the features? And you do that with the constraint flag, minus capital C. Remember, since this is a Slurm command or a Slurm directive, it has to be prefaced with hashtag capital letters SBatch. Then minus capital C, and then the type. And the type is one of these we have up here. You can also combine them. You can say that you have and or. Of course, you can say and with these because it cannot both be Zen3 and Zen4, but it could be both GPU and Zen4 or AMD or something. So this is an example here. And if you are combining, you need them wrapped in either apostrophes or quotation marks. There is an example, I believe, here. I think improve features. Yes. So here I'm telling it I want it to be either Zen3 or Zen4. And I want it to be a GPU that has AI features, which also is something you can tell it. That means it has tensor. In this case, you could also say that you want a specific GPU, but maybe you don't care which one of them it is as long as it has these features. So this is a way of combining features. And there is also a long list on the documentation pages. But in any case, if you want GPUs, you can use either a specifier to GPUs equals type and the number of them, or as a constraint together with just asking for GPUs or just asking for how many per node. The one that is recommended, I believe, is doing minus GPUs equals how many and then minus C, which type. No, it was this one. Sorry. The thing was that there are some MPI jobs where MPI run fails if you specify GPUs with this command instead of using this one. So don't use this one for MPI jobs. It also shouldn't happen if you use srun instead of MPI run. So you can also ask for GPUs with certain features. Any NVIDIA GPU, any AMD GPU, GPUs with single precision, double precision, AI features, half precision lower, or GPU ML features also half precision and lower sometimes. There's also the large memory node, so you can specify it quite precisely what you want. In most cases, you probably just want a GPU, and so you just say that. Aside from using the large memory nodes, there are other ways to get more cores by getting more memory, namely by asking for more cores than you need. And you do that with the minus, and this is a small c, and the number of cores, or minus cores per task and the number of them. It should be an equal between. And then only of them, then only use some of them for running. So for instance, you could say, I have 8 tasks and I want to use 2 CPUs per task. That means that you get twice the memory from 2 cores for each task, so twice as much memory. And yeah, just some examples, including I also show you the base one, the small examples you can run. So if you just want any GPU and don't care what, then you can do it this way. If minus GPUs equals, say 1, if that's what you want. Another way to ask for any kind is minus GPUs per node equals 1. One thing to pay attention to, that if you do this, you should not ask for more than 2, because if you go up and see here, then you can see how many GPUs cards are per node. And if you say, I just want any GPUs and I want 2 of them, or I want 4 of them, then you can't get 4 because there are none if you end up with these ones. So if you want 4, then maybe you should specify that you want, say, this one. So if you just say I want 2 and I don't care which kind, then you just get 2 random ones. But you can also use minus GPUs equals the number you want and then the type. So here is an example. I want 2 GPU cards and I want it to be V100s. So I say capital SBatch, hashtag SBatch, minus GPUs equal 2. And then I also put a constraint. I say it has to be V100s. Note this being the capital C. And then I get rid of any previously loaded modules. And then I load the modules I need. In this case, I load FOSS-CUDA, which is the GCC compilers and OpenMPI, and also BLAS, LATEPACK, SCALAPACK, FFTW, and so on. And then also CUDA. The newer versions of FOSS don't have CUDA. Then you load FOSS, and then you load one of the CUDAs. You can find various types of CUDAs, and they should work with all of them. And of course, it has to be a program that is actually GPU enabled that you're running. So note that you need this course project. If you're running the examples that are in the exercises section under simple, then I have replaced all of the project IDs with the current one. So there's this line in all of them. If we open one of them, let's do it with nano. So you can see this is an batch script asking for resources for an MPI job and then running it. And here I put the project ID for the current project. You can change it if you want to run in a different project, or you can just run in this one. This project, you will be in that for another about 2 weeks, so you can test stuff out. After that, I will remove people from the project because I'm reusing the project for another course. And here you can see I ask for how many tasks and time. So, but you can make changes to, and this was nano and not VI. So I'll just exit and then say no, I don't want to save it. So let's see how you do it on Open on Demand instead. So on Open on Demand, you did, as I showed before, do an interactive job that is actually starting a batch job so that you can run in an allocation on a compute node. And now, instead of starting the Kebnekaise desktop, I mean, you could start the Kebnekaise desktop, load a module, and then run the job for that program inside it. And that will be an interactive job on that compute node. But if you actually want to use one of the ones that are available, the MATLAB or the RStudio or Jupyter Notebook or VS Code, then you can start it from up as a interactive job directly instead. And, okay, let's go ahead and do this exercise together. So first, get a browser, and in that browser, window here, and log in. So now I'm logged in. So let's first again start the Kebnekaise desktop. I'm going to move this out a little bit, so I want to be able to see this over here. So I want to do this exercise here, and I would like you to type along and try doing it as well. So first, I am going to say that the desktop environment, I can pick any one of these two. Mate looks like GNOME, if you've used that. XFCE is the one I'm running here, so it looks like this with some start menu or play record. But I'm going to use Mate, and then I'm going to pick the 2025 151 here. And compute project should have been HPC2N 2025 minus 151, because this is the storage space, not the project. Number of hours, I'm starting with 1, because then it starts faster. Then pick something 1 to 4. I'm picking 4. Or maybe I should pick less so that they're more available for you. And then I'm just going to go with any, just like I did earlier. And then I launch it. I have the previous one. You can see that has stopped running because it's completed. It was only 1 hour, but this one is now starting. I got it on BCN 1702. I got 2 cores. I'm going to launch it. Now inside of this here is used for copying things from outside. I'm going to start a terminal window. Applications, System Tools, Made Terminal. It's here. I'm going to go to my project storage. I should probably increase the size of this. What I could do instead here is that I could open this file browser and pick file system. And then I could pick project, Novagog, for the courses there. And inside my directory, and then exercises. Simple. I will answer the question in 1 moment. And now I'm in the directory I want to work in. Then I right click, and then it should be possible to open. If not, I think we should do that. Okay, apparently not. But previously, I could open a terminal window inside here. Let's see if we can do that something. doesn't look that way. That's annoying. Nope. Okay, in that case, you have to go to this directory and to your own space. And then to exercises. Simple. Okay, and before I continue, I'm going to take the question.
Right. I posted a screenshot to the chat. But if I want to go launch Kebnekaise desktop, I received this error.
I think there was someone else got this error. Pedro, do you remember what the reason was for this? Didn't we see someone else have this error?
Yeah, let me see.
Because it may be above.
What about if you just close this?
Just try close it with the pop-up, yes, and see if you can go to it.
Yeah, you mean I closed it already. I mean, sorry, I cannot even interact. I can. Okay.
Because I think it's a bug and that it may be harmless.
Okay, then
if it doesn't work, then you can close the VNC window and then relaunch the session.
Yeah, that is this window here. So, I mean, you can just close here and then you can relaunch here. Then it's still running. That is also one thing that's worth saying.
Yeah.
This keeps running until you actually click delete or the time runs out. So if you close your window and open it again, it looks the same.
Yeah, I see. I have another error message. Maybe I should start it from the. I should start the interactive session from zero and then.
No, for this one, I am not completely sure about this error, but I just do don't delete. Yeah.
Okay, now yes. Now
And
it's
then
okay. Now
you will get the menu and the yes.
All right. Yeah.
Yeah, because we have seen this error before.
Yeah.
But,
okay.
And
right
we are
now
going
it's
to
fine.
install a newer version, then hopefully it will go away. Okay,
right.
but it works now.
Yes, thank you.
Okay. Okay, so everyone did notice that as long as this runs until you either click delete or this time you asked for runs out, then you can just close it and you can relaunch it and it's still there. So, okay.
One thing, yeah.
Hmm?
Yeah, and if you go to the My Interactive Sessions, you can see that you can increase the image quality. Yeah.
Yes, you can.
But I just use the default because maybe it could be a bit slower depending on the graphics that you are displaying.
Yes, and depending on the node you ended up in, I think.
Yeah.
Yes.
I use the default.
Yeah. But now I'm here and I'm in the directory here and I'm going to run an example. And you can try, as I say here, to do srun/bin/host name, just to see that there are several cores. In my case, 2, because I asked for 2. So as you can see. So let us try run the small Python program that's called mult is matrix multiplication. To run, and it should be here, this one. And in order to run it, I need to load some modules. So let us do that. Module load, and I'm going to load GCC 1230. And now I can only load a specific version of Python because that is the only one that has this prerequisite. You can see here, I got Python 3.11.3 just as here. I also need SciPy bundle, and the SciPy bundle is a number of Python packages. There are very few packages included with Python here. I do pip list. You'll see there aren't very many, but you can load the SciPy bundle, which includes NumPy and some other things. So module load. I think SciPy bundle should be able to load directly here, but let's see. Yes. And as you can see, SciPy bundle also pulled in some other stuff, including OpenBLAS. And in any case, we can now do pip list again. And now there are much more, including things like NumPy that I need for this as a package. I do, however, also need matplotlib. So I will also, but first I will try run this mmult.py that I can run directly. So I will say Python mmult.py. And it's doing its thing as it should. It's only it's taking a little time because it's I think I upped it, the size of it. I'm going to check how much I did. I upped the size of the matrix in order to test some other things that may be too large for the situation. All courses. Yes, it's pretty large, so it will take a while. We can try killing this. I actually just put it in the background with this command here. With top, you can see it's still running somewhere. Pretty far down it looks. So it's not using a lot of resources. I'm going to ignore it. Anyway, I'm going to go in here and I'm going to change it. I'm simply going to make it a lot smaller. And since I will need this again in a little while, I believe I'm just going to comment it out. I'm going to put these down to 8 and 4. They'll be very small. Again, almost immediately. But when I need it for the batch job, then I actually still need it to be large. The reason for that is that I want it to run for long enough that you have time to look at it in the job usage. So you can just go ahead and make the matrices a lot smaller and then make them larger again. So it's just copy those two lines and comment out those two that you are not using, and you can swap between them. That would be easiest. I will next time do that in the exercise. So let's try some Python and graphics. And this I will do only to show that graphics is available here. But we are running everything on the compute nodes that we allocated. And I'm going to ask for matplotlib as well. So I will load that. And since I also need TK intern for it to work this way, I will load that as well. That. Now, as you can see here, there is a data set, and I'm going to work on that. I'm going to start Python. And then I'm going to import pandas. I'm going to import matplotlib. And then I'm going to use tk-eggs, and that is for the graphics. It may actually set things correctly without doing that, but it doesn't if you run it from the command line regularly. SSH, but I'm going to do the same thing here, so we have that. Let's read in this CSV file. Let's publish this. Set the data frame. All right. Set a wired. This Scottish Hills spreadsheet. What's CSV file? So let's plot it. Do a scatter plot. And then let's show it. And as you can see, it doesn't show it. That's nice. Because if you're running it as a regular batch job, then you would instead have had to save this plot to a file, and then you could look at it afterwards. Okay. So this was the Kebnekaise desktop. And you can see I still have this here, and I'm going to delete it because I don't want it to run for 41 minutes without me doing anything in it. So I'm closing it. And then I'm going to start and randomly pick something. Let's do the Jupyter notebook. And here again, you pick the compute project, the number of hours. I'm just going with one. And you can pick any CPU, GPU, large memory, course. And then there's one thing that's different here. That is also going to be the case for RStudio and such, which is that there's a runtime environment that you can create. And you need that in order for if you want to add other modules or other, make a new Jupyter kernel with other modules in it. and you can create that, and they actually have some suggestions to how it looks. And you'll find those in this here, PFS Data Portal Jupyter Base. And there are some examples that you can use to create your own custom environment. And I'm not going to do that here because we will soon be out of time. And I also want to do a number of other exercises. However, I have described how to do this on SPC2N's documentation. So here is described how you also create the extra modules in it. So how you copy this file that you find under here to a specific directory, and then you make some changes to it. The only changes you do is that you load the modules you need in that. And then when you have saved that, then you can pick it here, as I have here. And then you can start Jupyter with not just the base Python, but with a number of other modules loaded. You can also start in a specific working directory. You choose pick path, for instance, which is also useful. And then you'll launch. And then after a little while, it starts a Jupyter notebook for you. I'll just start it, and then I will continue with the next session. But this is also nice, and this is something many of our users have to use. So. I will continue. You may wonder, when should you use Open On Demand and when should you use a regular bash script? So Open On Demand are good if you have shorter jobs, because you can at most run 12 hours, but also jobs in general that needs a lot of interactivity, because often you may just want to create a bash script and then just kick it away and then let it run for hours or days on its own while you do other things. But it's good for interactivity, it's good for graphics. It's not good for very long jobs or for very parallel jobs that needs more than 28 cores, for instance. Or if you have something that has multi-steps where several things have to be done in a specific order. You can do that with dependencies, which is described on our website always, so that your script will not start until the previous one specific one has run with success, if it, for instance, creates some data or whatever. So use Open On Demand for anything where you need interactivity, and use bash scripts otherwise. And I am going to